Welcome back. In this lesson, we'll learn what the information ratio is and how it compares to Sharpe ratio. Let's jump right in. We've learnt the Sharpe ratio in level 1, which measures the excess risk-adjusted return of a portfolio. The excess return is in reference to the risk-free rate. If we plot return against the portfolio standard deviation, the risk-free return should plot here, and the portfolio return should plot somewhere here. The slope of the line that intersects the 2 points is the Sharpe ratio of the portfolio. Different portfolios should plot at different points, and the one which has the steepest slope has the highest risk-adjusted excess return. An important attribute of the Sharpe ratio is that it is unaffected by the addition of risk-free asset or leverage in the portfolio. An investor who wishes to take less risk may invest in the risk-free asset together with the portfolio with the highest Sharpe ratio. Likewise, an investor who requires higher return should leverage at the risk-free rate to long the portfolio with the highest Sharpe ratio. Both investors will have the same Sharpe ratio. The information ratio measures excess risk-adjusted return of a portfolio with reference to the benchmark return. Note that the denominator is the standard deviation of the excess return over benchmark. The numerator is known as active return and the denominator active risk. Both the Sharpe ratio and information ratio can be used to measure ex-post performance or estimate ex-ante performance. When estimating ex-ante performance, expected values are used. While ex-post information ratio may be negative due to underperformance, ex-ante information is almost always positive. Obviously, managers have to expect positive active return, else they would not want to pursue the active strategy. So let's say the benchmark portfolio plots here on the risk-return chart. We would expect an active portfolio with positive IR to plot somewhere above it. Also, it would make sense for the active portfolio to plot above the line representing the benchmark's Sharpe ratio. Otherwise, a passive investor can simply long the benchmark portfolio with leverage to achieve a higher return. Such a portfolio has a lower Sharpe ratio than the benchmark. Two investment strategies can help reinforce the conceptual distinction between the Sharpe ratio and the information ratio. First, a closet index fund is one that is purported to be actively managed, but in reality closely tracks the underlying benchmark index. As you would expect, such funds will have risk-return profile very similar to the benchmark. Consequently, such portfolios have a Sharpe ratio very similar to the benchmark, and the information ratio is very low as the active return is close to zero. After fees, the information ratio of a closet index fund is often negative. Second, a fund with zero systematic risk that uses the risk-free rate as its benchmark would have an information ratio that is equal to its Sharpe ratio. This is because active return will be equal to the portfolio's return minus the risk-free rate, and active risk will be equal to total risk, as the benchmark risk is zero. You may mistakenly think that the slope of the line that connects the benchmark return to the portfolio return is the information ratio. This is not correct, as the portfolio risk is not the sum of the benchmark risk plus the active risk. It is the total variance of the portfolio that's equal to the sum of variance in benchmark portfolio and active variance. The active risk between these 2 points is therefore the square root of the difference. This means that the same IR that connects the 2 points is a curve. Rather, if we plot the active returns against active risk on its own, the slope of the straight line that connects the zero intercept to the portfolio return is the information ratio. The benchmark portfolio should plot here, as it has zero active return and zero active risk. If a portfolio follows the exact weights as in the benchmark, the active returns and active risks should also be zero. However, as deviations are made to the weights of individual securities, the active returns and active risk of individual securities become non-zero. The active return of the portfolio as a whole may be higher than the individual securities due to the benefits of diversification. Unlike the Sharpe ratio, the addition of the risk-free asset or use of leverage will affect the information ratio. This is because active return is measured relative to a non-cash benchmark, so the addition of the risk-free asset will likely lower active return, while active risk should not change much, so the information ratio of the portfolio will likely decrease. For an unconstrained portfolio, that is, the active manager has no constraints in extent of deviation from benchmark, an optimal set of weights can be determined, such that the information ratio is maximized. This straight line also implies that if we combine an actively managed portfolio with an allocation to the benchmark portfolio, the resulting blended portfolio will have the same information ratio as the original actively managed portfolio. Any blended portfolio that lies along this line should have the same IR. Investors can select an appropriate amount of active risk by investing a portion of their assets in the active portfolio and the remaining portion in the benchmark. For example, if the active risk of a fund is 10%, an investor seeking to limit active risk to 8% can do so by investing 80% in the active portfolio and the remaining 20% in the benchmark portfolio. This is important to determine because the active portfolio may not have the highest Sharpe ratio. As we've learnt earlier, the portfolios along this curve have the same IR. So, as you can see, there is one particular portfolio along the curve where the Sharpe ratio is the highest. The optimal amount of active risk can be calculated using this formula, and the Sharpe ratio of such portfolio can be calculated using this simple formula. Based on the optimal active risk and IR, the expected active return can also be calculated. Thankfully, you do not need to know how these formulas are derived, and if you could not understand anything from this lesson, make sure you memorize at least these 3 formulas and learn how to apply them. And let's end with an exercise. The KG Ultimate Fund is benchmarked against the prominent world index. The fund is unconstrained and has an active risk of 10%, at which the expected return is 6.5%. An optimal portfolio P is to be constructed by combining the Ultimate Fund and benchmark portfolio. Given the following characteristics of the benchmark and a risk-free rate of 2.5%, determine the optimal active risk for portfolio P, its expected active return, and Sharpe ratio at the optimal level of active risk. Pause the video now and work out your answer. And we're back. Let's first calculate the Sharpe ratio of the benchmark, which we'll need for the calculations of the optimal risk. You should get 0.25. The other figure we need is the information ratio of the fund, which we are told the fund has an active risk of 10% and expected return of 6.5%. Do note this is the expected return, not the active return. The IR of the fund, which is the active return over active risk, is therefore 0.2. With these two, we can calculate the optimal active risk using the formula. You should get 6.4%. And at this level of risk, the expected return works out to 1.28%. The Sharpe ratio of the optimal portfolio is also easy to calculate, that is 0.32. Next, we've determined that the optimal active risk of portfolio P is 6.4%. With that, determine the proportion of KG Ultimate Fund and the benchmark in portfolio P. Pause the video now and work out your answer. And we're back. We're told the KG Ultimate Fund has an active risk of 10%, while the active risk of the portfolio should only be 6.4%. As such, 64% of portfolio P should be in the KG Ultimate Fund, and the remaining 36% in the benchmark, which has 0 active risk. And that concludes this lesson on the information ratio and its relationship to the Sharpe ratio. Next, we'll learn the fundamental laws of active management. See you again.